Hi, and thank you for joining me on this data analysis with pandas and Python. We are going to do an analysis of the data analyst job listings, a data set from Kaggle, and really see if we can understand where the most money is made and where the happiest, the highest rated employers are. So start off by importing or connecting or mounting our, Google Drive, and then we're going to import our standard pandas, NumPy, seaborn, and pyplot libraries. We're then going to import the data set from, I have it set up so it's importable from my Google Drive, my GitHub reservoir. So let's just take a peek at that drive, and we'll see, we take a peek at this, and we see we have an unnamed column and an index column. So we'll get rid of that first because we won't end up needing those. And we have the just standard index right here, which appears to be the same values. Okay, so we have that. And so just to drop those getting started, we're gonna drop them. So df.drop, and then the name of the column, unnamed 0, and then dropped index as well. And so we're gonna do this in place. So we're gonna do this across axis 1. And we're gonna do again for the second one, in place equals true, and then access equals 1. So it's dropping the column when we do this. By default, it would drop an ax or a row, and I need to spell drop right. And I ran the first one, so it's probably going to drop this column, and I'll just run this again now, and we should see that we have 15 columns. Perfect. Okay, great. So we're going to, just to mix it up a little bit, we're going to work with pandas a lot today, but we're going to make it like it looks like seaborn, so it'll be extra fancy today. So we're going to do import matplotlib dot style dot use, and then we're going to pass the string seaborn. You can do ggplot, bhm. There's a handful of them. Just give it a little bit different style to, and really everything is based on matplotlib, so it changes the style of most graphic engines. Okay, so there we go. And here we're going to do, it's good to start off checking our null values so we can understand where our null values are. So we have null values in competitors and easy imply. And let's see if those appear in the same data sets or in the same row. So we're going to do competitors. Here we're going to do in parentheses. We're going to do our first logic statement, and we're going to go, here we're going to go is null and wrap that in parentheses, and then df, make sure there's parentheses around both sides here, and then is null, and then dot shape on the outside of this. So make sure each one of those logic statements is wrapped in parentheses, and then is null is your logic function today, and so it's going to give us trues and falses of that. And dot shape will give us, there's 400 rows and only 15, so 400 rows appears for the same for both of them, so we know that both of those rows are kind of repeating for both of them. Okay, so what we're going to do now is we're going to put everything into lowercase. Just so that you know, I didn't find this when I first did this. I went a little bit further in my workflow, and I came back up to the top of my workflow because I realized that this needed to be done, just so that everything was a little bit more workable. And so I came back up and did this after I found this out later on. So just so you know, I didn't know this the first time I came to this. So we're gonna go 4 feet, and in df columns, df feet. So this is gonna be the list of the column names, feet, and then we're gonna go str string dot lower. This is going to go through each column and essentially create a lowercase version of that column, kind of paste it on top of itself. So now everything is lowercase. Be a little bit easier for our analysis today. So just looking at the value counts and getting started with job titles. So we're going to break it down by different sections today. So job titles to get started. Again, we have lots of job titles. We also have some repeating, so we'll have to see what we're going to do about that. So here what we're going to do to get started is we're going to go df.value underscore counts. Just trying to understand how many times each specific value appears, and then so value counts. And then what we want to do is plot kind bar fig 12, so 12 width, for height on fixed size, so width and height on fixed size. We're going to do plot title, most common job titles, and then ticks equals rotation. Okay, and right here in the title, we want to make sure we go font weight equals bold. Why is it font weight? I don't know, it seems like a funny name to me, but anyways, font height. We get a nice little title on top of our plot here. So, okay, nice little plot. And so here we're going to do job titles. We're going to clean up our job titles, get rid of the Analyst 3, 2, and stuff, and just kind of look at them without those extra suffixes to the value. So here we're going to go string dot replace, and we're going to do the 3. We're going to do the 3 eyes, 2 eyes, intelligence, Salesforce, and senior. So let's replace those. And then here, let's look at this again. So we're going to do, again, we looked at 20. So our title dot value counts. We're going to take out the first 20, so 0 to 19, and then plot kind equals bar, and fixed size equals 12 by 4. A tuple of 12 by 4. Here we'll do in plot dot title, we'll do font size equals 20, and then right at the bottom we're going to do plot plt dot x ticks. Okay. There we go, if you can spell things right. Okay, there we go. And we have a nice little plot and a little bit more cleanup. We can see business analyst is really a hugely important job title. It seems to be the dominant one. But I think something to understand about data analysis is really, once you know data analysis, it's kind of, you can be agnostic to what the data means, the underlying data means in the real world, and really just analyze the data. And so really, I think these two, data business analyst and data analyst, are very interchangeable terms as well. Okay. So here, just looking at the salary estimates, and we'll do the dot value counts first, and we can see there's lots of stuff going on here. So we're gonna have to clean that up first to get started. Okay. So here we're gonna do salary estimate dot string replace, and we're replacing the Glassdoor estimate, and just to note that we're putting the slashes in front of this so that it does not ignore the special parentheses, which is a special character in regex. So just putting those, just to note that we're doing that to not replace it, or so that we replace it, and we're putting our values, and then we're replacing it, putting the salaries cleaned in the next ones, and then getting rid of the $sign and then the K. So we'll run all of those, and we should get a nice now cleaned data frame that only has these two values. So a high and a low value. Still not workable, so we'll have to do a couple things to make this a little bit more workable. So let's take the column, apply a string dot split to it. It's going to split this on the hyphen in the middle. So this creates a list of two values based on where it's split it. Not super helpful to get started, but what we're going to do is we're going to make it helpful. To show one thing that might not be the most commonly known way to use an if statement is just to show this. So I'm going to set a variable x equals 0. I'm going to say if x equals 1, then I'm going to do 0, else 1. So if I run this, what happens is we get an output of 1. So we got the else 1. And so what this is this was not 0 if this was 1. So if x equals to 1, so we should get a 0 output now. So this is do this if this equals this, else do this. And it's a little bit harder, but we needed this in this workflow today to make this function work. So we're going to use this function down below, salary average, to either, if the length is equal to 1, so if it only has one value, we're just going to return that value to value. Else, if the length is 2 or greater, we're going to then go 0. This had to work because there's a blank value in the first position sometimes. So with this, I had to say if it's blank, so else 0, if x0, the first position, is equal to blank string. So if it's equal to a blank string, give it a 0, else do the float of that value plus the float of the second position, then divide by the length. So first position plus second position divided by 2 will give you an average. So this is a way to get a simple average, although it's not clean, so we had to do a little bit of an interesting if statement to get that to work. Down below, we're going to go dot apply and then do the salary average that we just created. Okay, so run that. Oh, and I'm not done yet. So here we had to do, where I have the nuns, I meant to do that in blue, so it's more audible. We got to do x0 and then x1, so the first and then the second position. So let's rerun that and see if I can get this function to work perfectly. So now we're either getting just the single value or we're getting an average of the two values. So we get something that we can work with here. We'll apply this into a KDE plot here and see, take a peek there. We're going to do, to get the first job titles, we'll do value underscore counts, and that we're going to do 0 to 7, not including 8, and we'll get the index of that, and we'll give us a list of those values. We'll do plot.figure, and then we're going to do plot.figure, and it's is in job title. So we're going to make sure the job title column is in this job title list. So we're only going to get a plot of the 8 job titles that are most commonly occurring. Okay, so here we're going to do a boxing plot, and we're going to do y equals salary mean. So the salaries will be on the y, and job title across the x, but only the jobs that we wanted to see, the top 8 most common jobs. So we're going to do show flyers equals false, blind width 2. We'll do in plot.title font size equals 24, xticks, and plot.show. Okay, so we got a nice little plot there of our salaries by jobs, and we can see very distinctly different distributions depending on the data type or the job type. Okay, so here we'll do, just to confirm that, we'll group by job title. And so I have notes written underneath all of this, and there's a final summary. So I'm not going to spend any time in this video going over really what I've noticed in these distributions, but do read the notes that I have in this workbook, and I'm sure they'll be highlighted. Let me know in the comments if you disagree or agree, or you found something that I missed. Okay, so going into the next column, so I just did df columns to inspect the column titles, and the next one was rating. So I looked at rating with value counts, and you can see we have a lot of stuff going on. We have a lot of not really ratings at all, some random stuff put in, so we need to clean that up a little bit. So I'm going to create a list of all these random values, the -1, Jacksonville, Florida. I don't know why these are in rating, but they are, so we're going to clean them up. And so I'm going to create a list of those, and I'm going to go create a function that we're going to use in the next section. So we go if x is in rating class, then we'll return numpy equals nan, else we're going to do, or numpy.nan, else return x. So if it's not a null value, we're going to return a solid value. Or sorry, if it's a relative value, we're going to fill it with a null value, and then. Okay. So here what we'll do is we're going to apply clean rating. So we'll apply the function that we just created, and we can see now we get a nice clean reduced data frame with just numbers that we can now work with. We're going to go as type float. So this is a float and a numeric feature, and I need to spell as type correct. Okay, and so here what we're going to do is we're going to do a hist plot, sns.hist plot, and we'll do 36 bins. Underneath we'll do plot equals title and histogram of rating and font weight bold. I just noticing that I'm doing a line break in front and after the histogram, the title, just to give a little bit of space. I feel like it fits in a little bit better. It's not so squishy. Okay, so here we're going to use value counts, and we're going to select the first 6 for value counts. We're going to get the index of that. So we're just getting the index values of the value counts. And I like using value counts versus .unique, because it gives you can select which ones occur the most often. So .index is a way to do that. And here we're going to go down in the figure size. Now that we have job title list, we're going to go big size, and then underneath we're going to do sns.violin plot, and we're going to go make sure it is in job titles. So we're going to make sure job titles is in the list above that we just created, and you can expand this if you wanted to look into more job titles as well. So violin plot. You need to make sure you spell things correctly. Python is very, very finicky about correct spelling. And so the good thing, there's an only limited number of things you need to remember how to spell. Okay, so moving on to location now, getting the value counts of this. And so we can see we have a city and a state. So let's separate those into a list. So let's go string dot split and split on the comma space. So we're going to separate those, and we get a list of then the city and then the state as well. So here we'll create two little functions, get city, get state. And what we're going to do here is if the length is 2, as you can see here, some of these items aren't. They have some other random stuff in there. So if it is 2, we're going to return the 0 value, right? So if it's 2, we'll return the value. So we're checking if it's the length to make sure it has 2 positions, return the city. And then here down below, we'll go if length is equal to 2 again, then we'll return the position number 2 because we will hopefully get the state. And so we'll get our states. And then what we'll do in the function down below, missed something. So here we're going to return the second position. Make sure you're filling all those none values. Got to pay attention. Okay, so here to get underscore city, the function we create up above, and we'll get underscore state. So now we have the state and the city values extracted from the location, and we have quite a few cities. So I didn't really do a lot with the cities, but you're welcome to kind of explore this a little bit more. And here we have states. We don't have so many states. There's a good number to work with and kind of further our inspections. So here what I'm going to do is data equals df in the violin plot, rating equals clean by state. I'm going to do plot.title and plot that histogram of the violin plots of those values right here. Okay, so if we do plot.figure next, and we'll do SNS dot violin plot, and we're going to do the salary means by the state. And remember, we only have 6 states, so we don't need to do any logical indexing on this one, which is nice. And we'll do plt.title. And I wrote histogram here, but this should be a violin plot. So just make sure to correct my spelling mistake if it's still incorrect. Okay, so violin plot. So getting into size now. So we'll see we have a size, lots of different values here. It was pretty tricky to figure out what to do with this, but what I decided to do was we're going to go sizes dot value underscore counts, and then we'll go index, and we're going to take the first 5 or 6 values, sorry, of the index, and we'll use that list again to logically index and select those rows. So we'll go title, or sorry, not title, bigger and big size. Then we'll go violin plot, data equals size, and then we're going to go is in sizes, so in the sizes, and you can play around with the number of that you would want to inspect. In plot.title, we're going to do font weight equals bold. Okay, got that one done. Perfect. Okay, moving on to the next one right here. So we're going to do, we got the figure, the violin plot, and we need to do the logic statement in here. So is in sizes. So this is in sizes. And our X, our category, is the sizes across. So we're grouping by our X axis, and we're sorting those around. Okay, we'll do the same thing. So just, I wanted to inspect a little bit further because there was some things that were not the size, but private or public. So I wanted to inspect that as well. So I just created a list. Here is very short, it's 2 items. And so I created a list of those values so that we can inspect when those are true. And you can see here quite a big difference, actually, truthfully, bigger than any other category. So just, you can use a short list like this. If it was 3 or 4 values, it'd be a little bit too long, but it's a short, easy list to just kind of stick inside the function. Okay, so the next thing we're going to do here, so we're going to do industries, but we don't want the negative. There's a negative value in industry. I think they did that when there was no value. So I want to say when it's not equal to 1, when industries is not equal to 1, I'm going to reduce the data frame, and then I'm going to just only select the industry column, value counts, and then return that index. So I won't have, basically trying to get rid of the -1 when I get this list of index values. I'm going to do plot.figure. I'm going to do right down here below, I'm going to do a boxing plot, And we'll do the same thing that I've done before. Is in industries, X is our salary mean, which will go on our y-axis. Industries is our category, which will go on an x-axis, and we'll essentially group by that value. Box in, and you need to spell the full word box and plot. And there we go. Okay. And then moving on to our next one here. So we'll do SNS dot box and plot x ticks rotation equals 40. Right there. Okay, perfect. Beautiful. Even. And so here we're going to do sector next. Do the columns going through the sector. And we're going to go here. And we can see we got the values here. We got lots of different values in this. And we're just going to get the first 8, like we've done in the last values, using dot value counts, dot index. We'll go plot dot figure here, get the fig size. We're going to do box and plot. And then we'll do data equals df. And df is the data frame that we're giving it, is in sectors and is not equal to -1. So kind of very similar to the problem we had up above, but just solved it in a different way. Okay, we're going to do salary mean and then x across those two values across the sector, across the x-axis. The mouthful. Okay, so here we go. And doing the same thing of the rating as well with the box and plot by the sector. Okay, so we're on the last section. We're going to do value counts. And we can see we have a lot of -1s, which I'm pretty sure meant unknown. But here what we're going to do just to get this, we have a lot of, and it's not a list. It's kind of like a list. And so if we go string str dot split, we'll split it on the string, just like we've done before today. Not interesting by itself making a list inside of the column, but if it's a list inside of a column, we can use dot explode and essentially create a new row for every item inside the list. So in this one, that's Robert Half is going to have its own column, Agilon is going to have its own row, and Aerotech is going to have its own row. So be 3 rows, everything will repeat, except in competitors will each have its own unique value. Okay. So we can see if we do the shape, we get a much bigger data frame. And if we look at the competitors, we can see here that Microsoft, Google, and Apple are all at the top, no surprise, but Accenture is the #1 by far. And so it's very interesting. Less known technology company is actually really one of the biggest competitors to most people for data analyst job. And in our final summary is a summary of really what my findings were, just to kind of summarize and put in good context. Let me know if you disagree, and don't forget to like and subscribe. I will see you next time. Bye.